Now let's look at example 5 of our lecture notes. In this example, you have a student that connects a photocell to a supply and finds that when the cell is exposed to monochromatic radiation, a current will only flow when the potential difference across the cell is less than 1.6 volts. And you are asked to find what's the maximum energy of these emitted electrons. Of course, what you may want to ask is actually what is a photocell? Okay, so a photocell is simply similar to the setup of an photoelectric experiment. Is simply a cell in which you can shine light on it. It has a cathode and an anode, such that when you shine light on it, there will be electrons that are emitted. So in this experiment, what you can do is you can actually apply a potential difference across the cell. And you are told that if you have the potential difference that is less than 1.6 volts, then there will be a current flowing through. If it's greater than 1.6 volts, then there is no current. So this information also tells us about the polarity of the cathode and anode. It simply tells us that the anode must be at a negative potential to the cathode. So it's able to stop the electrons from moving to the anode. Okay, and this 1.6, what's the significance of this value? We have a name for it. Yes, this is the stopping potential in our photoelectric effect. And for this question, we are looking at the maximum energy of the emitted electrons. So what is the electrons emitted with? What kind of energy? Yes, it is kinetic energy. So looking at the question, what we have is we are asked to find KEmax and we are given the stopping potential. Do we have a relationship for that? Yes, we do. The maximum kinetic energy is equals to E times Vs. Do we have the value of E? Yes. Do we have the value of the stopping potential? Yes, we do. So we can now determine the answer. So E itself is 1.6 times 10 to the power minus 19 coulombs, and the stopping potential is 1.6 volts. And putting that together, that will give us our answer to be 2.6 times 10 to the power of 19 joules.